Energy Code Compliance for Metal Building System Part 3 webinar will review in detail the insulation prescriptive compliance options for ASHRAE Standard 90.1. The past webinars, we reviewed a broad overview of the IECC in 90.1 in Part 1. Part 2 reviewed in detail the 2015 IECC prescriptive provisions for insulation for metal building system. This webinar will focus in on the 2013 edition of 90.1. Part 4 will take a look at the trade-off method. In particular, we'll take a look at the R value method and the U factor method. And our primary reference documents will be the 2013 standard, and a lot of the information contained in this and other webinars are within the second edition of the Energy Design Guide for Metal Building System. This can be obtained on MBMA and ASHRAE Standard on ASHRAE.org. As a reminder, as we reviewed at the end of Part 2's webinar, is in order to navigate to ASHRAE Standard 90.1, the IECC does allow this. If you go to Chapter 4 of the IECC Scoping Provisions, it first points you to 90.1. The 2015 points you to the 2013 ASHRAE Standard. In brief, let's take a look at some code text. Code text is obviously formatted differently from what's in the IECC, but in general, you still have the R value and U factor method, along with the prescriptive trade-off method and the performance method. But let's take a look at the prescriptive building envelope option. For a conditioned space, the exterior building envelope shall comply with either the non-residential or the residential requirements in 8 separate tables. Tables 5.5-1 through -8 for the appropriate climate, and this refers back to the climate zone map. If you have a building that contains any semi-heated space provisions as we outlined or defined in Part 1 of the webinar series, you would also take a look at the same tables. So this points you to 2 space conditioning types and the climate zone map. Going down to 5.5.3, Note A refers to the R value method. The R values of the insulation within the framing cavities or continuous insulation only, and the assembly descriptions or specifications, as it notes here, are listed in Appendix A. So we won't spend a lot of time on the assembly descriptions since they align with what we reviewed in the Part 2 webinar. So we'll skim through those. And then the U factor method is outlined here. So you can either use one of 2 methods. For all opaque surfaces except doors, the compliance shall be demonstrated by one of the following 2 methods: the R value method and the U factor method. There's also the C factor, the F factor, and that refers to the slab on grade or other insulation options outside of what we typically focus in on as far as the roof or the walls. Again, it points you to the assembly descriptions in Appendix A. So this is that first table, Table 5.5-1. So the 1 correlates to Climate Zone 1, which correlates to Climate Zone 1 such as the tip of Florida. And we'll review the layout of these tables here shortly. But just quickly rolling through the various tables, you have table 2 for climate zone 2, 3, 4, 5, 6, 7, and 8. Sorry about all that. And we'll take a look at climate zone 6. We'll arbitrarily pick one or two of these. But for climate zone 6, we have this information. So we still have roofs and the same roof categories as we've reviewed in the IECC. The same wall categories: mass walls, metal building, steel frame, wood, and the other, along with walls above grade, floors, slabs on grade, and opaque doors. You also notice that it is not within the IECC. They combine the fenestration prescriptive information within each of these tables as it varies per climate zone, whereas the IECC had a separate table for fenestration such as windows, doors, and skylights with window or glazing areas. Notice the semi-heated space columns. Residential, this aligns or is equivalent to the IECC, where it talks about the group R, so sleeping spaces within commercial building occupancies, and then the non-residential, so outside of group R, or outside of the residential, I should say, as defined in 90.1. You also notice this table includes the R values and the U factors per occupancy, or per space conditioning type, I should say. Semi-heated, residential, or non-residential. And the IECC broke these out into two separate tables. So for the R value method, we would use the R value column. U factor method, we would use a U factor column and ignore the insulation options within the R value listings. So let's focus in on climate zone 6. I extracted the roof and wall information out of the full table 5.5-6. And as mentioned, this is broken down into two space conditioning types, one for semi-heated and one for fully conditioned, whether it's residential or non-residential. So for metal building roofs, we still have the note A, which assumes a thermal spacer block. We have the LS liner system as outlined within Part 2 webinar. We've reviewed what is a liner system. A liner system has two layers of unfaced fiberglass. One is compressed at top of the purlin, other is uncompressed, that is laid on top of the vapor retarder, which has already been pulled through the metal banding, longitudinal and transverse. And then the unfaced fiberglass rests on top of that. So the purlin has been concealed. This semi-heated includes two layers of insulation, where the first layer is installed perpendicular to the purlin, compressed at the purlin in a standing seam roof for this particular example, and the second layer is also installed, but it is installed in parallel to the purlins. First layer is faced, second layer up above is unfaced. This note A, regardless whether you have two layers, double layer, semi-heated, or the liner system, assumed you have an R3 thermal spacer block, which is outlined in Table A 3.2.3. For metal building walls, you notice it's all CI. Again, CI we reviewed in Part 2 CI refers to continuous insulation. And it could be rigid board, it could be spray foam, it could even be insulated metal panels if the seams avoid thermal bridging. But for our case here, we're just showing the continuous insulation as rigid foam board as one of the many options for continuous insulation. Continuous insulation means that there's continuous R value, so it's uncompressed from one framing member to the next. If you had a fiberglass system, for the single layer fiberglass system, obviously it would be continuous, it would be compressed, but the fiberglass would be compressed at the girt, for one example, or at the purlin. You know, these two examples does not equal the continuous insulation definition. Continuous insulation or rigid board could be installed on the exterior or the interior. So for this case, for the semi-heated space, for the R value method, we would go R 9.8 interior, exterior, so roughly 1.5 inches of rigid board. But when you get to the conditioned space for the R value method, you would use about 3 to 4 inches of rigid board or another type of continuous insulation system. And that's all you have. If you recall, in the IECC has a fiberglass plus continuous insulation. You'll notice this in older versions of 90.1. But this was removed in the 2013 version, and I believe it goes across all climate zones. So that's the R value method. The U factor method, for any of these, you would go back to the nationally recognized resource such as ASHRAE Appendix A, and go to the metal building table or the metal building wall table, the roof of the wall table, to pick out an assembly that meet these U factors or is slightly less than these U factors. Remember, the lower the number, the better thermally, more thermally efficient. Climate Zone 3 has less insulation. Notice the single layer fiberglass for the semi-heated. And this also now has a filled cavity system. FC correlates to filled cavity, which is not the same as a liner system. So climate zones 1 through 3 in the 2013 standard, if you're going with the R value method, you would need to install an R19 plus R10 filled cavity system. And what does that look like? Well, it looks very similar to a liner system. However, the purlin is exposed. The lower layer has a vapor retarder or a facing, and basically has a longer tab left over that is lapped on top of the purlin and secured by the fasteners. So even though there's still steel banding that's holding up the lower layer, which would be the R19 in this case, this will be faced and the purlin is exposed. A liner system does not expose the purlin. The upper layer is the smaller of the two R value numbers, so for this case it would be R10. You still have the R3 thermal spacer block plus a standing seam roof if you're going with the prescriptive R value method. And this is just a quick illustration of the single layer R16 over the purlin compressed. For the walls, you still have the option to go with the fiberglass system, but that's really regulated to the semi-heated space provisions in the warmer climate zones. And then it brings you back in the continuous insulation for the conditioned spaces. So that's the R value method. U factor method allows you more options. But before we provide the options, let's define the cavity-filled systems. The ASHRAE 90.1 includes assembly descriptions for the filled cavity, and it assumes a standing seam roof in an R5 thermal spacer block. I believe on the last slide I said R3. Got confused. That's more so for the liner system. But R5 for the filled cavity system per the assembly description. And for the liner system, it assumes an R3. Now again, you could use product manufacturer system. They would have other assemblies tested with and providing a U factor that may have an R3 thermal spacer block for a filled cavity system, or other options that you may want to consider. But for this ASHRAE non-proprietary system, the assembly description provides what is allowed. This was reviewed already in part 2, so I won't spend a lot of time. Just notice the length of the arrows kind of illustrates the amount of heat loss or thermal bridging at the framing members. Obviously less thermal bridging as the cavity is filled with insulation. So the lower the number, the better performing the system. And these U factors are derived by hot box tests, computer modeling, and now calculation methods for metal building roofs and walls in the later 90.1 standards. This is the 90.1 resource I was referring to in the last slide. This is Table A 2.3.3 out of 90.1. This focuses in on assembly U factors for metal building roofs. I broke this table out into 2 parts. The first part provides information on single layer systems, double layer systems, liner systems, and this first column makes note of the R value system, or numbers of layers of insulation, and the associated U factor in this other column right here. And it takes account any thermal bridging due to purlin spacings, assuming the space is about 5 feet on center. And if it includes a standing seam roof, it would include the 1.5 inch standing seam roof standoff clip, and that'll be noted in a footnote here on the second portion. That's noted in Note A for the standing seam roof clip provides a minimum of 1.5 inch distance from the top of the purlins to the underside of the metal roof panel system. So this is the other part shown on the full page out of 90.1. And then this gets into the filled cavity system with thermal spacer blocks. And take a note of the notes. This footnote C assumes an R5 thermal spacer block. Again, this assumes a standing seam roof. For this falls underneath this main category over to your upper left-hand corner of the screen. And further on, standing seam roof without thermal spacer blocks, you'll notice for the liner system, the R19 plus R11 system has a U factor of 0.04, and that is less efficient than a standing seam roof with thermal spacer blocks. Come back over here, the R19 plus R11 has a 0.037. So the smaller the number, the more thermally efficient. And then moving on, you have through-fastened roofs without thermal spacer blocks, of course. Thermal spacer blocks are not commonly used with through-fastened roofs because of the longer fastener needed. So if you do run into a situation where it's being specified, please check with the roofing manufacturer or the metal building manufacturer to see if that would work with their roof system. And so this notes, single layer system, and has one liner system option here. When you get into a semi-heated space, oftentimes semi-heated space are used for warehouse or agricultural conditions, and this is where a through-fasten roof is normally used, but that's not always the case. Through-fasten can be used on conditioned spaces. But if you run into a semi-heated space, you'll notice less insulation requirements. You may get away with using a single layer system. So let's see what we were referring to back a few slides. We were looking at options for climate zone 6. We wanted to have a U factor of at least 0.031 for a conditioned space and a 0.06 for a semi-heated space. One option is to go continuous insulation only, and this table provides that option. Notice here we have a rated R value of insulation. It says none on the second column, upper left-hand corner. That means just for the metal roof panel only assumes an U factor of 1.28 is 0. And then you add in your continuous insulation. So you could use a system on R15.8 will get you roughly a 0.060, which would get you to your semi-heated threshold. And for the conditioned space, you would need to put in a lot of continuous insulation. So roughly 1 inch is about an R6.5, and that would vary per product supplier. Some has systems as an R5.0 per 1 inch. So as you can see, it gets pretty thick as you get up into the lower U factor numbers. Second option would be go with fiberglass plus continuous insulation, and that may be used more for retrofit applications where you already have fiberglass systems in the building, probably to meet older energy code provisions. So you may only have a single layer system or a double layer system, and you want to bring it up to today's energy code limits. So there you could put in a layer of continuous insulation, and so these are just some of the options to get to the 0.031 or less, depending on how much fiberglass insulation you might have. Even if you have a through-fasten roof system, you can also do the same. Or simply revert back to the R value method if you don't find a system here, and thereby just using the R25 plus R11 system for the climate zone 6, or R19 plus R19 for the double layer system for the semi-heated space. This is the same table, table A2.3.3, but this is from the latest published version of 90.1, 2016. It is just reformatted a little bit differently, and it adds one minor change based off an approved addendum, which we'll get to here on this slide, this portion of the slide. Addendum AP modified 90.1 2013 to include a second filled cavity system with thermal spacer blocks. So an R19 plus R11 system. Otherwise, the table remains the same, just color-coded differently. Hopefully it is easier to read and navigate. And again, if you are using an older version of the International Energy Conservation Code, which may not reference 90.1 2016, which it won't until the 2018 IECC becomes available. But even if you are on like an 09 IECC, or you are, which references the 2007 90.1, in order to meet the U factor provisions within IECC, you are allowed to use the most recent version of 90.1, which includes the latest industry U factors. So you'll notice more and more assemblies have been added as the years or versions go on. And that'll be more evident in the wall table for metal buildings. Okay, moving on. This is the table for walls out of the 2016 version. And you will notice that there are new wall systems. This was derived from Addendum CP, which updates 90.1 2013. It includes a single layer in cavity, which I believe, discussed previously, at least in part 2 of the webinar systems here. So this is a single layer, fills the cavity, and then there's 2 layers of fiberglass. So this provides more option for the metal building industry. If they want to use fiberglass, they can still use continuous insulation systems, which one option is just go all continuous insulation. Another option is just use a single layer system, which is more common to semi-heated space. And in order to meet these options that we keep showing up for climate zone 6, you still have these 3 options here. I believe these will be highlighted here. So R6.5 or R13 continuous insulation will meet climate zone 6 provisions, or you can use a fiberglass plus continuous insulation system as highlighted here. R19 plus R13 continuous insulation will get you to 0.05. Or you can use this new system, R25 plus R10 will get you down to 0.047, which will meet the conditioned space provisions. As long as you are a little bit lower or meet it, then you will be fine. A little bit more information about Addendum CP and these new single layer in cavity and double layer systems. The single layer in cavity is really basically provides a single layer fiberglass which could be faced, or that facing could be separate. So for the vapor retarder, it could be adhered to the fiberglass or have a separate sheet. And there is no compressed insulation between the girt and the wall panel. There is a requirement, at least if you want to use the U factors out of the prescriptive, or I should say out of the U factor table for metal building walls in Appendix A, it assumes you will have a thermal spacer block or a brake strip tape. For the level that they're asking for, it would be a brake strip tape. And then you get on to the double layer system. This one does have 1 layer compressed. And you may or may not be required to put in a thermal spacer block or a brake strip tape. It all depends on that table. And then the second layer is installed on the interior, uncompressed, and it may be faced or have a separate membrane installed. So hopefully that information was useful. If you do run into situations where you want to add a little bit more fiberglass into the system. There are other methods to meet the provisions. One is to do a 2 or 3 dimensional finite element modeling. So you would probably touch base with the insulation supplier or the metal building manufacturer that you are working with. And then they would also have hot box testing results that would show the system that you're wanting to use based on your purlin or girt spacing, the type of insulation you want to use. So you do not have to use the insulation systems that are outlined in 90.1 or even in the IECC, as long as you find a system that meets or exceeds the U factor provisions. And of course, if the latest version of 90.1 includes the calculation methods. So you can do that for the single and double layer systems. And now for the cavity filled wall systems via Addendum CP. And upcoming, there will be some changes that will allow you to calculate cavity filled roof systems. So those are under development within the ASHRAE process. So look for that maybe later on in 2017 or early 2018. In summary, I summarized metal building roof prescriptive tables for the past 4 code cycles, going back to 2004, 90.1. You'll notice for the condition space provision, it's all single layer, only when you get up into climate zone 8, where you have 2 layers, double layer sag and bag system for climate zone 8. And then things start to change when you get into the 2010 version. Notice the increased levels of insulation, and then dramatically so, where you have your filled cavity systems, FC, and your liner systems for the 2013 version. So these systems remain the same in the 2016 version of 90.1. And moving on to walls, same thing. The older versions, less stringent. The newer versions, more stringent. Even now into the 2013 version, it's all continuous insulation for the walls. If you desire not to go that route, you now have more options within Appendix A table for the new single layer in cavity and double layer systems, especially into climate zones 5 through 8. In summary, the semi-heated space provisions are shown on this slide out of the prescriptive tables. And you'll see more stringent when you get into 2010 and 2013 version. There was no changes noted for the 2016 version here as well for semi-heated spaces. So what you see here is what you'll have in the most recent published version of 90.1. So that concludes part 3 of the webinar series. Please refer back to part 1 and part 2 for more information, more general information on how to meet the prescriptive provisions of both the IECC and 90.1, and then we get into a little bit more detail in part 2 for the 2015 IECC. Please look for part 4, which will get into how to use the trade-off method if you want to move away from the prescriptive compliance method. And so this will provide an avenue to understand how to use the ComCheck, and we'll provide a couple case studies for you to analyze. As always, feel free to contact us if you have any questions about these webinar topics, or if you have a project in the future where you need some assistance in order to understand how to meet the energy code provisions. With that, we will end this webinar for part 3. Thank you for listening.